on the subject matter, chemistry alternative to practical GCE. Okay, we come to you with another probable question. Okay, and in this question, as you can see on your screen, a student was required to standardize a solution of HCl using 0.125 mole dm cube sodium thiocarbonate 4. So it means we want to standardize the solution of HCl, which means we don't know the concentration of HCl, but we know the concentration of sodium thiocarbonate 4 Na2CO3 to be 0.125 mole dm cube. The student titrated acid against 20 cm cube portions of sodium carbonate, so which means our pipette here is 20 cm cube. Okay, we have a table there. Of course, we have average titer value. And the first question we asked on A1 is, name the piece of apparatus used for measuring the sodium thiocarbonate 4. Of course, the sodium carbonate here is our base, so what we use for measuring that is our pipette. That's our pipette. Our pipette is what we use for measuring that. That is A1. On A2, we're told to identify 3 errors in the results presented. Looking at all this, you see the rough, okay, no arithmetic error. You see the first titration, no arithmetic error. You see the second, third, no arithmetic error. But on the second titration, we have inconsistent Brent readings with respect to decimal point. The initial Brent reading there is to 1 decimal place, so that is inconsistent. Another thing is that if you look through all of the table, no mention of the unit of our Brent readings, so no unit. And also, when you look at the average titer value, the rough is totally out of it. We are not meant to use the rough. But for the first, second, and third titration, the first titration 22.75, the second titration 22.5, the third 22.40. The first titration is very far from the second and third, so which means the first titration was not consistent. So therefore, we are not meant to use it to find the average volume of acid use or the average titer value. So using that 22.75 means what we have there is wrong averaging. So those are the errors I can spot there. That ends that. Then on question B, as you can see on your screen, we were told to state the color of phenolphthalein in sodium carbonate. What is the color of phenolphthalein in a base? That is question B. B1. What is the color of phenolphthalein? Phenolphthalein in sodium thiocarbonate 4. What is the color of phenolphthalein in sodium thiocarbonate 4? Of course, that is red. That is red. If you recall our table for indicators, that is outrightly red. Okay, that ends that. Then we were also asked B2, is phenolphthalein a suitable indicator for this titration? Without much ado, no. B2, is phenolphthalein suitable? The answer is a capital NO. No. What is the reason? This is a reaction between HCl. You see, we were asked to give reasons. Okay, reasons. We have HCl. HCl is a strong acid, and then we have sodium thiocarbonate 4, which is a weak base. When we use phenolphthalein is actually, in this case, when you use phenolphthalein goes with weak acid versus a strong base. So what we have here is a strong acid versus a weak base. So that is what makes phenolphthalein not suitable for this experiment. Phenolphthalein is used for weak acid versus a strong base. So, and that is not what we had here. So that ends that. They said, what effect would the acid have on litmus paper? Of course, it will turn blue litmus red. So C, for question C1, what effect will the acid here is HCl. What effect will the acid have on litmus paper? It is going to turn blue litmus red. It is to turn blue litmus red. And that ends that. Of course, after the bread had been washed and rinsed with water, that's talking about C2. After the bread has been washed and rinsed with water, what final cleaning steps should be taken before filling with acid? Before you fill with acid, you are meant to still rinse with the acid to be used. You rinse with acid to be used. The main acid you want to use for the titration is still the main acid you will use to complete your final rinsing process. Yes, you'll be using the acid to do your final cleaning up step. Okay, that ends C2. And then on D, for question D, we were told to calculate something. They said using an assumed titer value of 25.45. So which means I am given VA for this is for question D. I am given VA. I'm given VA to mean 25.45. 25.45 cm cube. Determine the concentration of HCl in mole per dm cube. Concentration of HCl in mole per dm cube. Of course, when you look at the whole of okay, the equation has been written for us. The volume, the number of moles of the acid is actually 2. And when you talk about your base, the volume of my base is going to be the volume of my pipette, which is given as 20.0 cm cube. And of course, the concentration of the base, as given from the start of the question, is 0.125 mole per dm cube. And of course, the number of moles of the base, from equation is 1. So it's very easy for me to calculate the concentration. Ca is going to be Cb Vb times Na divided by Va Nb. Okay, with this, my Cb is 0.125 times 20 times acid is 2 divided by volume of my acid is 25.45 times 1, number of moles of my base. If you compute this, you're going to get 0.213 mole per dm cube. 0.213 mole per dm cube, and that is just about your answer for question. We were told calculate the mass of anhydrous sodium carbonate required to prepare 250 cm cube of 0.125 mole dm cube. We are looking for the mass. Don't forget, concentration is actually mole divided by volume in dm cube. But in this case, my mole is going to be mass over molar mass. Now the volume is in cm cube, so volume in cm cube, and 1000 is going to go up. So I'm looking for my mass here. So what is my concentration? My concentration from the question is 0.125 mole per dm cube equals to the mass I'm looking for times 1000 for sodium triiodocarbonate for Na2 CO3. If you calculate the molar mass, it is 106 times the volume is 250 cm cube. Okay, so having this, my mass is going to give me 0.125 times 106 times 250 divided by 1000, so that my mass is, if I compute this, 3.31312 gram. That is the mass that will be in 250 cm cube of 0.125 mole per dm cube sodium triisocarbonate. So with this, we've come to the end of these questions. All you have to be conversant with the instruments we use for titration, errors that can be in our table, the colors of our indicators, when to use each indicators, and of course, your titration formula CAVA over CBVB equals to Na over Nb, and of course, how you deal with your molar concentration, your mass concentration, and of course, stoichiometry, good knowledge of stoichiometry. When you are conversant with this, then you will know what to do. So with this, we've come to the end of this. I wish you the very best in your titration question chemistry alternative to practical GC from myself and the team. It's bye for now.